Hello everyone. In today's lecture, I'll be showing you how to solve a linear programming problem using graphical method. Well, there are various methods to solve linear programming problem like simplex method, graphical method, then big M method, etc. But in this lecture, I'll be showing how to solve this LPP using graphical method. So, this graphical method can be used to solve linear programming problem only when there are two decision variables. As you can see from this question that maximize z is equal to 12x1 plus 16x2. Here z is equal to 12x1 plus 16x2 is the objective function subject to the constraints, that is 10x1 plus 20x2 less than or equal to 120 and 8x1 plus 8x2 less than or equal to 80 are the constraints. So in these constraints you can see there are only two decision variables, that is x1 and x2. So graphical method can be used to solve LPP when there are only two decision variables in the question. More than two decision variables when are present in the question, then we will use other methods for solving that type of linear programming problem. So there are various models for this graphical method, like in one question you will get to see that maximize the objective function and there are two constraint equations as shown in this slide, like the question 1. Here in this slide also you can see the question 1, that is maximizing the objective function which is subjected to two constraint equations. Another problem is that minimize the objective function which is again subjected to two constraint equations. So I'll be showing you the graphical method technique using three different types of questions. One will be the maximization problem subjected to two constraint equations. Another is the minimization problem subjected to two constraint equations, and the last question that I'll be showing you is again maximization problem, but here the constant equations are 3. So in this lecture I'll just be solving the first question and the next two questions, that is minimization subjected to two constraints and maximization subjected to three constraints. I'll solve them in the next lecture. So starting with the first question, that is, this is the linear programming problem. I have to maximize this objective function which is subjected to two constraint equations and there are two decision variables only, that is x1 and x2, using graphical method. So the steps are, since there are two constraint equations, I have marked them as equation 1 and 2. So first taking the constraint equation 1. First I will be converting this inequality constraint equation 1 to an equation, to an equality equation. So I have converted this inequality constraint equation 10x1 plus 20x2 less than or equal to 120 into an equality equation, that is 10x1 plus 20x2 is equal to 120. Now this equation is the equation of a line. So in graph, when I have to draw the line which is represented by this equation 10x1 plus 20x2 is equal to 120. So you can draw this line on the graph, and there are various methods of finding the points and then plotting that line on the graph. But I will be telling you that one method how you can draw that line that is representing this equation is, first you take x1 is equal to 0. And for x1 is equal to 0, you find x2 from this equation. So putting x1 is equal to 0 in the equation 10x1 plus 20x2 is equal to 120, I will get x2 is equal to 6. So this is the first point, first set of point that I've got for the equation 10x1 plus 20x2 is equal to 120, that is x1 is equal to 0 and x2 is equal to 6. Now for finding the second point, second set of points for this equality constraint, that is I'll be putting x2 is equal to 0, and for x2 is equal to 0 I need to find x1. So again putting x2 is equal to 0 in the equation, 10x1 plus 20x2 is equal to 120, I got x1 is equal to 12. So I have got two sets of equation, that is x1 is equal to 0 and x2 is equal to 6, and the next set of equation is x1 is equal to 12 and x2 is equal to 0. Now using this set of points I will draw the line on the graph. So this is the graph. The x-axis is the x1 variable and the y-axis is the x2 variable. Again I am repeating, in this graph the x-axis is the x1 variable and the y-axis is the x2 variable. So I have plotted the points, that is first I told you that I got two set of points, that is x1 is equal to 0 and x2 is equal to 6, and x1 is equal to 12 and x2 is equal to 0. I have plotted both the points on the graph paper, and then I have joined those points to get the line of that equation. So next, so I have obtained the line for the first constraint equation. The next step I'll be doing is I will be taking the second constant equation, that is 8x1 plus 8x2 less than or equal to 80. This second constant equation marked as 2, equation number 2, I will convert it into the equation. Again I will find two set of points, that is two set of points for x1 and x2 from these equation, and then I will plot it in the graph, join the points and obtain the line. So in this slide I have done it like this only. 8x1 plus 8x2 is equal to 80 means I have converted that inequality constant equation into the equality constant equation. So here again I have to find the set of points, repeating the same technique as I have told you just now, that putting x1 is equal to 0 in the equation I will find x2, and again in the next step putting x2 is equal to 0 I will find x1. So in this way I will get two sets of points. So putting x1 is equal to 0 in the equation I found x2 to be equal to 10, and putting x2 is equal to 0 in the equation I found x1 to be equal to 10. So therefore the two sets of points that I obtained from this equation are x1 is equal to 0 and x2 is equal to 10, and for x1 is equal to 10 I got x2 is equal to 0. So again plotting these points on the graph and joining these points to obtain the line, I will get the line for this equation 8x1 plus 8x2 is equal to 80. So in this slide I got 2 points, that is x1 is equal to 0 and x2 is equal to 10, and x1 is equal to 10 and x2 is equal to 0. I got both the points and I have joined both the points to obtain the second line for the second constraint equation. Now next step is I have got two lines for the two constant equations mentioned in the question. So next step is to shade the area. I have to find the feasible region. For that I need to shade the area which represents that inequality constraint equation. Means I have first of all just see from the first constraint equation I got the first line, that is 0, 6 and 12, 0. So now I have to shade the area which represents that inequality constant mentioned on the question. Now which is that shaded area? Either it is above that line or below the line. So that can be obtained. You have to go to that constant equation. Since I have told you that 10x1 plus 20x2 is less than equal to 120 is the constant equation 1, and I have already shown you that how to obtain the line from this inequality constant, that is by converting the inequality constant into the equality constant, that is 10x1 plus 20x2 is equal to 120, and then obtain the line. Now with the line and with respect to this inequality constraint, that is 10x1 plus 20x2 less than or equal to 120, shows the area will be less than the line, that is the area will be below the shaded area will be below the line. Similarly, if you can see the second constraint equation 8x1 plus 8x2 less than or equal to 80. So I have also obtained the line for this inequality constraint by converting the inequality constraint into the equation and then plotting the points on the graph. I obtained the line. Now I have to find the shaded area, whether it is above the line or below the line. So as I can see that the inequality constraint is 8x1 plus 8x2 less than or equal to 80, means the shaded area will be less than the line. Or if you are confused regarding this, you can do just one thing. For both the constraint equations, taking both the constant equations, put x1 and x2 is equal to 0. For example, in the constant equation 1, when I will put x1 and x2 both equal to 0, I will get 10 into 0 plus 20 into 0, that is your 0. And this 0 is obviously less than 120. Means when you will put x1 and x2 is equal to 0 and put it in the constant equation, then if the equation gets, that inequality constant equation gets satisfied, means the shaded area contains that 0 point. So from these two, if you apply that technique, that putting x1 and x2 is equal to 0 in the constant equation, then you will get to see that both the constant equations, the shaded part of that inequality constant equation will contain x1 and x2 is equal to 0 point. So what I have done is that I have shaded the area, and now the next step is I will find the overlapping of the shaded area. Since both the shaded area are below the lines, now where I have to find the intersection of both the shading area and the overlapping shaded area is this region that I have marked it as visible region and shaded it with the line, as you can see from this slide. Now next step is to find the corner points of this shaded area. As you can see, the corner points of this shaded area that is marked as visible region are 0, then 10, then 8, then 6. So I have named these 4 corner points as A, B, C and D. Now you can easily find A, B, D, but if you have any confusion regarding finding the point C, because you are able to see that these two lines are intersecting at the point C, and if you are not able to find it properly from the graph paper, you can also find it by solving the equations. For that you have to take both the equality constant equations, means you have to take both the equality constant equations, and they are 10x1 plus 20x2 is equal to 120 and 8x1 plus 8x2 is equal to 80. Solve these two equations simultaneously and you will get the intersection point, which will come out to be 8, 2. That is x1 is 8 and x2 is 2. So now the next step is, now I have found the corner points of the shaded area. Now next step is, since the question is of maximization type, what I will do, the next step is I have to take the objective function. I have to put all the 4 points. I have to put all the 4 corner points into the objective function and see for which set of point does the objective function give the maximum value. So in the next slide I have shown you this, that A, B, C, D were the set of points, or you can say were the corner points of that shaded area. So I have put all that A, B, C, D points in the objective function given in the question, that is 12x1 plus 16x2. So as you can see, the A point refers to 0, 0, that is x1 is 0 and x2 is 0. So I have put x1 is equal to 0 and x2 is equal to 0 in the objective function, and I have found the value of the objective function. It has come out to be 0. In the next step also I will be taking the next corner point. Okay, in next corner point, that is I have taken B. B refers to the point 10, 0. So I have substituted the value of x1 and x2 in the objective function to be x1 is equal to 10 and x2 is equal to 0, and I have found out the objective function and it came out to be 120. So in this way for all the 4 corner points, I need to find the objective function by substituting x1 and x2 with their respective values. So from these you can find the objective function that came out to be are 0, 120, 128 and 96. So among these points you get to see for the point C. C is the point referring to 8 and 2, that is x1 is 8 and x2 is 2. So C is the point for which I will get the maximum objective function. So the solution of this question is that x1 is equal to 8 and x2 is equal to 2 are the points, that is the value of the decision variables, or you can say after solving the value of decision variables that came out are x1 is equal to 8 and x2 is equal to 2, for which I got the maximum objective function, and that is equal to 128. So up to this point in this video lecture, the next 2 questions I will be solving in the next video lecture. Thank you.